And so this is where the risk integral comes in. It's pretty straightforward math. I don't know why people are so afraid of integrals, but all you're doing is you're combining the hazard curve and the fragility curve together, because you're combining the different probabilities, and you get a risk of collapse. All right, because now, before, our fragility curves were a function of spectral acceleration, but that spectral acceleration has its own probabilities. Okay, and so that's like a conditional probability. All right, which is what we had here. So if we take the different components of this, we talked about the different hazard curves and the different spectral, the probability, conditional probability of failure as a function of spectral acceleration. We put them together and you get your risk of collapse. And so Nico Luca's done a lot of work on this for the USGS. And so this is where he's got a lot of presentations and papers that show the importance of bringing in this risk of collapse overall for the national maps. Okay, because what we want to do is we want to have a uniform risk of collapse across the entire country, right? So why would you have more risk in one region and then why in another? Okay, and things get interesting in the next step. And so you'll see that, for example, he's comparing Memphis and San Francisco, that our 2% in 50 years is pretty much the same. They have very similar accelerations, 1.4 versus 1.5 Gs, okay? So the uniform hazard spectrum is going to give you the same design values, but the hazard curves are different, okay? This is that total, because they have different sources. Maybe in the Memphis only has one big fault or one big type of fault, while San Francisco has many different ones. And so the shape, because you're adding different hazard curves, comes in and it's different. And so this is when people talk about the slope of the hazard curve, because now you're going to integrate it over a whole, from 0 to infinity. So the whole shape comes into account. So this is on the top left. We've got, our hazard curve. We combine it with a fragility curve. The USGS uses a uniform fragility curve, which with a beta of 6 and a 10% probability of collapse given the MCE. And so for these two sites right now, this would be the same hazard curve, just slightly different, okay? And I welcome you to learn more about this. If you do this and you integrate the two, you get the numbers that the probability of collapse in 50 years in Memphis, in the blue, is 7%, while in San Francisco, it's 1.5%. So now we don't have the same risk of collapse. So what the process goes through in determining a uniform risk is at what point do we take this curve, the fragility curve, and we move it left and right until it's an iterative process, until the two curves, the risk curves, come out to be the same. Okay, this is something that the building code does. They use a simple model, but in the building, this is what USGS does, the mapped ones, but you're welcome to do this yourself as well and use, maybe a more accurate fragility curve. So if you move around this fragility curve left and right to find out at what spectral acceleration will you get the same probability of collapse, this is the process that you go through. And so this is, the very last step. In the risk integral, you see that this is the example. This is something he wrote in 2006. He was looking at 1.5%. Now we look at 1%. The two sites have the same probability of collapse, but they've had to shift the same fragility curve, which means that now our ground motions for San Francisco are going to be 1.5 G, but the ground motion that we designed for to have a 1.5% probability of or whatever you want it to be is actually 1 G, okay? And that's where that risk coefficient comes in. All right, this was that in-between step, is what it was for the 2% and 50 and how that gets modified. Okay, and so this is the process, and I wanted to make sure that you understood. I'm every time I go through this, I understand this a little bit more. It's a very simple, it's just math.